Okay, so these are problems where you are trying to figure out how to match up the limit sigma definition of area with a definite integral. And the two big formulas are delta x and x sub I. Your delta x is b minus a over n. Your x sub I is a plus that delta x width times I. Sometimes the i's are k's. In this case, the i's are k's, so I'm going to change that to k. Now, I always start with the delta x, and delta x is always some number divided by n. And it is multiplying to f of x sub I. So all of this in my integrand, or not integrand, all of this in inside of my sigma is f of x sub I multiplied by the delta x width. So when I look at all of this, I am looking for a factor that is just a number divided by n. And I can see that right here. That is a good candidate for delta x. If that is delta x, that means that my a and my b are 5 units apart. So my integral is going to be from sum a to a plus 5 of f of x dx. Now, I'm going to take the 5 over n and I'm going to move it here to the x sub k formula. And then I need to decide what a could possibly be. 0 is always a possibility for what a is. If a is equal to 0 with a delta x that is 5 over n, then b is going to have to be 5. And my x sub k is just 5k divided by n. So if I look at setting aside the 5 over n that's already highlighted, I'm now going to look at the rest of this, and I'm looking specifically for every time 5k over n shows up, and that would be right here. If I replace that 5k over n with an x, and then I look at what is there that is not the delta x, that is the function. So if I choose a to be 0, then that forces b to be 5 if I have chosen the delta x to be 5 over n. And that means my function is the sine of negative 1 plus x. And then I have my dx to finish off my integral. So this is a possible definite integral that limit is finding the area of. And I look and I see that that is one of my possibilities. So this could be a definite integral. Now let's go back to the choice of a. So I'm going to erase, go backward. And if I choose to make a be a number that I see adding directly to a 5k over n, then negative 1 is a good candidate for a. B is going to be 5 larger because I chose to use the delta x, where b minus a is 5. So 5 more than negative 1 is 4. And this means my x sub k is negative 1 plus 5k over n. If I highlight the entire negative 1 plus 5k over n, then when I come over to what represents f of x sub I that is not the delta x part, which is highlighted in yellow, I'm looking for the entirety of negative 1 plus 5k over n. If I replace all of that with an x, then this thing that I have circled in blue is my f of x function being integrated. So that would be sine x. And I would be going from negative 1 to 4. And then I put a dx differential on the end. And then I take a look and see if any of my integrals match that, and number 1 matches it. So far I have 1 and 2 have to work. Now, if you're on a multiple choice test and this is your situation, you would probably pick D and move on to the next problem. But let's see how we could have made delta x a different number and still gotten an integral that would solve this. So going all the way back to the drawing board. I need a bigger eraser. Again, I have a delta x, which is b minus a over n. And instead of making it 5 over n, we could make it 1 over n. If we make it 1 over n, then only this over n part, with a times 1, is the delta x. So I'm going to emphasize by putting a times 1, and then I'm going to highlight just that little times 1 with the over n. There's my width. That means my f of x sub I that is being multiplied to delta x inside of this limit sigma has to be everything else, including this multiplication by 5 right here. So now when I get started on x sub I have to choose an a. The formula for x sub I is a plus delta x times I, although we're using k. If my delta x is 1 over n, then that means that my x sub k is equal to a plus 1 over n times k, or k over n. If a is equal to 0, b has to be 1 more than that because b minus a is equal to 1. And if that's true, then my x sub k is just k divided by n. And now I'm going to look for that k divided by n only. And I'm going to highlight just the k divided by n part and only replace that with an x. And now the function that I can see that is in these borders, I have a multiplication of this 5 multiplied by the sine of a negative 1 plus 5 times x. So that means a definite integral that works is 5 times the sine of negative 1 plus 5x from a equals 0 to b equals 1. All three of these are possible definite integrals for that limit. Let's look at another problem. If we are trying to just match this limit up with one definite integral, and it's going to be one of these four, then I can see that if I go from 0 to 4 or 1 to 5, my b minus a is going to be 4. So when I get started with my delta x, if it's going to fit in with any of these integrals, it has to be 4 divided by n. And when I look at my formula, besides the limit and the sigma part, 4 over n is multiplying. It's a factor, and I see a factor of 4 over n right there. That means that the rest of this is my f of x sub I, or in this case, x sub k. Before I go to figure out what function that is, I want to look at my formula for the x that is plugged into that function, x sub k. I have a starting number a, and I add the width k times. I'm using a width of 4 over n. So now I've got my x sub k formula almost done, but I've got to decide what a is. Based on my choices, a is either going to be 0 or 1. Let's start with what if a is equal to 0. If a is equal to 0, then b has to be 4 more than that, because b minus a is equal to 4. And if a is equal to 0, then my x sub k formula is just the 4k divided by n. So that means that I'm going to come back to my f of x sub k, and I'm going to look for every time 4k divided by n shows up. Right here I have a 4k divided by n, but I also have right here, the numerator could be changed to 3 times 4k, and then 4k divided by n is this also. Everywhere that I have 4k divided by n, I can replace that with an x. And I just realized I probably should have used a different color right here. So if I take what is highlighted in blue right here and replace it with a big giant X, and I replace what's blue right here and replace it with a big giant X, then the function that I see is 3 times X. That's starting to get to be too much. That's too noisy. So I'm going to ink this out, pretend it doesn't exist, and the entire blue is this through here, and that's replaced with an X. So my function f of x is 3 times x times the cosine of 1 plus x. And this is going to be found in an integral that is 0 to 4. So the question is, do any of these fit that? And the answer is, hey, look at that. That one does fit. So now you might ask, why don't these two that start at 1 work? So you can follow me along with why that is the case, or you can look at the next problem that I do and fast forward. So if I'm choosing delta x to be 4 over n, and if I choose my a to be 1, then 1 plus my delta x times k is this right here. Now, I have to set aside my 4 over n for my delta x. Then I have to look for everywhere that there is a 1 plus 4k over n. And the thing is, all of the k's and n's that I see inside this formula have to be dealt with. They have to be replaced with x in some way. So as I look at this, I can see that it works here, where I'm going to have just something times cosine x. But I then have to deal with 12k over n. And I've got to find within it a 1 plus 4k over n. While this is doable, this is not going to be pleasant. And the only way this is going to happen is if I have here some kind of addition or subtraction with my x. And when I look at my possibilities, I can see that that's not happening, that this is not going to work. Based on what is chosen here, I can't ignore k over n and just put a 12. And I can't use just 4k over n and ignore the plus 1 and let it be 3 times x. So those won't work. Now, I'm going to look at some of the homework problems that you had a while ago and try to figure out how to write these as definite integrals. I'll do 65 first. And I start back at the formula of what is delta x, b minus a over n. What is x sub I? A plus the width times I. And my delta x is always going to be some number divided by n. And I have to see that as a factor of the formula that is in this sigma, in this limit sigma. So I'm going to blow that up and look at it a little bit more closely. I have to take aside one of these n's. If I take aside one of those n's, then this has to turn into n cubed. Now, the constant that I bring with it, it looks like it's going to be easiest to just use 1 because I don't see any numbers that are multiplied in there. So now I'm going to try to zoom back down again. So we're going to try to make a definite integral by making delta x 1 over n. That means when I get my integral going, whatever number a is, my upper limit has to be a plus 1. When I go to my x sub I, if I choose a to be 0, then I have just the delta x, which I found to be 1 over n, multiplied by I. That means I'm looking for an I divided by n inside of a formula where this is the formula. My width, delta x, is one of the factors set aside. The rest of it is f of x sub I. And I am looking for just I divided by n in a formula. So if I play with it a little bit, I will notice that this is the same thing as I over n to the power of 3. Replace that I over n with an x, and you get that the function is x cubed, and put a dx on the end. And if I did choose a to be 0, then it's from 0 to 1. And that is my definite integral. That will be the same thing as the limit for number 65. Now, it is asking you to evaluate the limit by first recognizing it as a Riemann sum for a function. Oh, and it even tells me defined on 0, 1. So what I'm supposed to do at this point to finish up the homework problem is solve this definite integral, which is x to the 4th over 4, evaluate from 0 to 1, which is 1/4 minus 0. So the answer to that limit is 1/4. I'm going to now erase everything. And then we're going to do number 66. All right, starting again. Delta x is some number divided by n, and it has to be a factor. Now this one's written differently because it doesn't have sigma. Instead, it shows a pattern. So I need to look at everything after this limit. Delta x must be a factor within that sum. And it is a number divided by n. And there you go. There's a factor of the whole thing. And they said to define it based on a definite integral from 0 to 1. So that fits with 1 over n if my a and my b are 0 and 1. Now I turn to my formula for x sub I. My x sub I is always going to be a plus the width multiplied by I. If a has to be 0, then I'm looking at just the delta x, which is 1 over n multiplied by I. So that means I am trying to figure out, I'm trying to look for I over n in each of these. Now, if sigma is using, if I'm using the right Riemann sums, then my first I is 1 and my last I is n. So I'm looking for 1 over n, 2 over n, 3 over n. And I'm having trouble writing. I can do this. 2 over n, 3 over n, dot, 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 to n over n. When I look at what is not the factor 1 over n, and then I identify 1 over n, 2 over n, 3 over n, all the way through to n over n, I can see that each of them is representing an x sub I in my function, because my sigma is using the formula f of x sub I times delta x. I already have my delta x here. The sum of f of x sub i's is showing me over and over again the square root of the x sub I formula from I equals 1 to n. That means the square root of x is my function. So to turn this into a definite integral, the square root of x is my integrand. I am integrating from 0 to 1 times dx. And then if I solve this and find that number, that is the same as the answer to the limit. So integrating the square root of x and evaluating from 0 to 1, I am going to get 2/3 minus 0. So the answer to number 66 is 2/3. And so that takes you through a bit of how you can try to determine what definite integral is being represented by a limit sigma. Have fun studying.